Have you ever wondered how you can reach your destination, even though you're constantly covering half the remaining distance? This curious question is the seed of Zeno's paradoxes, a set of philosophical problems generally attributed to the ancient Greek philosopher Zeno of Elea. These paradoxes, though millennia old, still challenge our understanding of motion and infinity. They invite us to grapple with concepts that seem counterintuitive, yet are fundamental to our perception of reality. They ask us to question the nature of space, time, and the very fabric of our universe. One cannot help but marvel at the audacity of these paradoxes, daring us to unravel the threads of the familiar and plunge headlong into a world where the ordinary becomes extraordinary. Where infinity is not just a concept, but a playground for thought experiments. Intriguing, isn't it? Let's dive into the paradox that started it all: Achilles and the tortoise. Imagine a race where the swift-footed Achilles gives a tortoise, known for its slow pace, a 10-foot head start. Who would win? In the realm of everyday logic, the answer seems obvious. But let's venture into the world of Zeno's paradoxes, where things are not quite as they seem. Picture this. Achilles, the hero of Greek mythology, renowned for his speed, lines up for a race. His competitor, a humble tortoise. But being a good sport, Achilles gives the tortoise a 10-foot advantage. The race begins. Achilles, with his athletic prowess, quickly covers the 10-foot distance. But here's the catch. In the time it took him to run those 10 feet, the tortoise, slow and steady, has moved a little further. So Achilles runs again, covering the new distance between them. But alas, the tortoise in that time has again moved ahead, albeit by a smaller margin. And so, the cycle continues. Each time Achilles reaches where the tortoise was, the tortoise has managed to move a bit further. In this strange race, it seems Achilles can never overtake the tortoise. No matter how fast he runs, the tortoise always remains a step ahead. An amusing thought, isn't it? The greatest warrior of Greek mythology, unable to beat a tortoise in a race. But hold on a minute. Doesn't this contradict our daily experiences? We've all seen faster runners overtake slower ones. So what's going on here? Well, this paradox forces us to grapple with the concepts of motion and infinity. It challenges our understanding of space and time, asking us to reconsider how we perceive movement. Zeno, a philosopher from ancient Greece, crafted this paradox, amongst others, to question the very nature of reality. His paradoxes, though perplexing, have sparked countless debates and inspired numerous philosophical and scientific explorations. So, does it mean our understanding of motion is flawed, or is there a solution to this paradox? Stay with us as we delve deeper into this fascinating conundrum in the next scene. Now that we've seen the paradox, let's attempt to unravel it. As we navigate the labyrinth of Zeno's paradoxes, we find ourselves in the company of philosophers and mathematicians who've grappled with these conundrums across millennia. The first solution to our paradox comes from the ancient philosopher Zeno himself. He argued that motion is an illusion, a mere trick of the senses. But this, you might say, feels counterintuitive, as we experience motion every day. So let's move on to a more mathematically grounded approach. Enter the world of calculus, a branch of mathematics developed in the 17th century by Sir Isaac Newton and Gottfried Leibniz. Calculus provides us with the tools to dissect the infinite, allowing us to sum an infinite series of distances or durations. In the case of Achilles and the tortoise, calculus shows us that the sum of the infinite series of distances Achilles must run to catch the tortoise actually converges to a finite value. So, paradox resolved? Well, not quite. While calculus helps us understand the paradox better, it doesn't quite address the philosophical question at its heart. How can a sequence of events or steps, each of which is non-zero, add up to something finite? This is where the concept of potential infinity comes in. Potential infinity suggests that while you can always add another step or event to a sequence, the total number of steps or events remains finite until you decide to stop. This, combined with calculus, provides a satisfying resolution to Zeno's paradoxes. So we see the paradoxes are not about motion's impossibility, but about understanding infinity. It's about comprehending that the infinite can sometimes be broken down into manageable, even finite parts. It's a reminder that the world is not always as it seems, and that our intuitions can be fooled, especially when it comes to the infinite. And perhaps that's the real lesson of Zeno's paradoxes, to keep us questioning, to keep us thinking, and to keep us marveling at the mysteries of the universe. It's fascinating how an ancient paradox still echoes in our modern world, isn't it? Zeno's paradoxes, devised over 2 millennia ago, continue to shape our understanding of the universe. What makes them so enduring? Perhaps it's their knack for questioning our fundamental assumptions, challenging us to think beyond the obvious, to dig deeper. Take the realm of quantum mechanics, for instance. This mind-bending branch of physics seems to mirror Zeno's paradoxes, with particles existing in multiple places at once until observed, akin to the notion of infinite divisibility. Quantum entanglement, where particles separated by vast distances instantaneously affect each other, echoes the idea of infinite tasks in a finite time. Even in the field of mathematics, the paradoxes persist. The concept of infinitesimals, quantities so small they're almost zero, is a direct descendant of Zeno's paradoxes. Calculus, a cornerstone of modern mathematics, wouldn't be possible without grappling with these infinitesimals. So too in philosophy, where Zeno's paradoxes invite us to examine the nature of reality, time, and space. They push us to question, can we trust our senses? Is motion an illusion? Is time continuous or a series of discrete moments? These paradoxes are more than just ancient riddles. They're catalysts, sparking debates, inspiring innovations, and driving our quest for knowledge. Zeno's paradoxes, therefore, continue to spur our quest for a deeper understanding of the universe. As we've seen, Zeno's paradoxes serve as mind-bending riddles that challenge our understanding of reality. These paradoxes, particularly Achilles and the tortoise, invite us to question the nature of motion and infinity. They remind us of the enigmatic beauty of philosophy, the joy of questioning, and the thrill of intellectual pursuit. As we delve deeper into the realms of thought and explore the vast landscapes of philosophy, remember that the pursuit of knowledge is a journey without a final destination. Thank you for joining me on this philosophical journey. Subscribe to Chasing Sunsets 49, and let's embark on more intellectual voyages together. Until next time, stay curious and keep chasing those sunsets of enlightenment. Take care.